Hey, what's happening, guys? So today we are looking at this Pevono DC power supply. This is PS305, which should be 30 volts, 5 amps. Now here it has some features. Small transient overshot volts upon switch on under full load. 3.45%. Sure, 3.45% sounds small, but that's still some transient, so that's not wonderful. Rising time with full load, 52 milliseconds. Smooth voltage waves upon shortened load. Efficient cooling by heatsink and a fan. Built-in 4 capacitors, among which 2 pieces are 35 volt, 470 microfarad. I think they mean capacitors, not compacitors. But hey, what do I know? Anyway, input 110 to 220. Output 0 to 30 volts, 0 to 5 amp regulated. LED display, 2x3 digit red 7 segment, 2x4 digit red 7 segment. Display accuracy, 0.5% plus or minus 1 digit. Linear regulation, 0.03% plus or minus 1 millivolt. Load regulation, 0.33%. So 1/3%, that's not too bad. Ripple and noise. That probably means noise. 3 millivolts RMS between 5 hertz and a megahertz. Linear regulation, 0.1% plus or minus a milliamp. Load regulation, 0.2% plus or minus 5 milliamps. And another ripple and noise. Anyway, protection, overload, overheat, overvoltage, and short circuit. Let's get it out of the box and have a look. Okay, so everything in the box, we have the power supply, and it is quite small. Look at compared to the size of my hand. IEC power cable, banana plugs to alligator clip, and the manual. So we'll plug it in, put it on a load, hook it up to a meter, see how accurate it is, and yeah, we'll go from there. Alright, for our first test, I've got it hooked up to the Fluke 8840A bench meter, and we're going to see the accuracy of its display. The word I'm looking for is display. We'll see how accurate the display really reflects what's going on there. So let's start with some fine voltage control, and we'll go to take it right to 1 volt here. So 1 volt is showing on the power supply. We're seeing 1.02 and some various digits on the Fluke. So reasonably close. Let's bring it up to, say, an important voltage like 3.3 volts. You know, a microprocessor voltage. Something that you don't really want to overshoot. So 3.3 showing here, and 3.3097, so 3.31. I would say that's close enough for government work. Take it up to our next common voltage, which is about 5 volts. 4.987. Undershooting there a little bit. Interesting. And from this point, we'll just kind of randomly go. There's halfway on the dial. 16.2 shows 16.222. Close enough. And at full range, 31.6 volts shows us 31.61. So the display seems to be accurately calibrated. No problems there. Alright, our next test is going to be a test of the accuracy of the display again, this time for amperage. And I have my little variable DC load set up here. And it's going through the Unity UT61E meter set for amps. And we'll see how accurately the display reflects what we get on the Unity. So 0.41 milliamps, 0.42. I mean, that's looking pretty good there. No problems at all. 0.81, 0.82. Now we're showing 1.115, 1.12. I mean, it's a digit off, but you know what? This thing is $60, so I think we're well within the range. And as I ramp up, we can go up to about 3 amps here. You should be able to see 1.881, 1.89. See, just like I said, about a digit or so off. Crank it all the way up here. Maximum power. 2.512 amps, 2.53. Yeah. That's all very close. No worries there. Seems to be an accurate display on both voltage and on current. Okay, our final test of the unit is going to be noise. So as you can see, we're running 2.9 volts at 250 milliamps through our little load tester. And I've got the oscilloscope hooked up, and we're going to come over here and take a look. Let me get everything in place. Alright, so what you're seeing now is that output pattern, and I'm running 32 averages on it, just kind of smooth things out here. And so if I bring up our cursor menu, and we're going to do voltage, and we'll bring our start down here, and our end to here, you can see we are getting 39.2 millivolts of ripple. And according to the specifications printed on the box, it said 3 millivolts of ripple. So 3 versus almost 40, it's a noisy supply. Doesn't mean it's a bad supply. Probably not going to want to use this in, you know, high frequency, high megahertz, gigahertz applications, or you're going to create yourself some RFI. But for general usage, it's quite respectable. Of course, we can't end the show without taking it apart and having a look, see what's inside. So, appears to be 8 screws. I'll take them out and we'll see what's up. Okay, so now we're looking inside, and look at this. Everything moves in different directions. You need that case to provide the rigidity. That's just, you know, cost reduction. Nothing special there. So we've got an N-channel MOSFET here. It is the heck is it called? P75NF758. And then over here is an ultra-fast diode, STTH1002CT. And that's duplicated on the other side as well, on nice aluminum heat sinks. Now, as for capacitors, they are Shenzhen Market Special of the Week Chang X. But they did take the time to put a little Celastic on there and make sure that everything is down nice and smooth. Same with this large toroidal inductor here. Everything is glued down to the board quite nicely. You see we have a X2 capacitor here. Nice polyester film cap. Here's a big RF choke. And then we have our main transformer here. And these, I believe, are probably filtering chokes here as well. Large power resistor here. And a bunch of surface mount chips. Okay. The last thing we're going to look at is this IC here. I know it's dark. I really can't get any more light into there. Let me see. Hold on. Let me try one last thing to see if I can grab some light in there. See if that helps. Does that help at all? Not really. It's a TI-494, TL494CN. It is from TI. And that is your PWM controller chip. That's the brains of the operation. Last thoughts. The construction seems well made. The ground is connected, and it is solidly screwed in there. A lot of times they leave these things flopping. Everything does seem to be well constructed, and this is a bargain basement. This is a $50-odd switching power supply. So I'm pleased with it. Now, in the spirit of transparency, this was sent to me free of charge by Pevono to review. But I tell you what, it has earned a spot on my bench. It's going to stay. I'm confident in it. I like it. There's a link down below. So I hope you guys enjoyed this. If you did, give me a thumbs up. Feel free to comment, share, and don't forget to subscribe. Big thanks to all my patrons. That's it. I'm out. Peace.